Now this is all about sketching this and identifying an oblique asymptote. Now I'm going to do this one by dividing. So x plus 2, and I've got x squared minus 5x plus 11. So x to go into x squared is x. Then we get x squared plus 2x. Subtract minus 7x plus 11. X to give us negative 17x is negative 7. So negative 7x. Take 14 and subtract, and we get 25 as the remainder. So we can say that y is equal to x minus 7 plus 25 over x plus 2. And the whole idea is that this bit here would be an oblique asymptote. In the usual way, the denominator here helps us identify x equals negative 2 as a vertical asymptote. So let's look at a sketch. So we have x equals minus 2. So that's a vertical asymptote. And then y equals x minus 7. That's a straight line, gradient 1, intercept here at 7, intercept here at 7 as well. And so that's a vertical asymptote and our oblique asymptote in place. And then we've got to figure out what the curve looks like around this. Okay, so if we put x equals 0 into this, we can find a y-intercept. So x equals 0 gives us 11 over 2. So 5.5. So 11 over 2, that's a y-intercept. And let's think about when x is more than negative 2. So if x is more than negative 2, the bottom would be positive. Something that's more than negative 2 add to would be positive. And I'm going to, I'd check this out a bit more thoroughly if I was doing it, but I'm assuming the top's positive as well. So positive divided by positive, and that would make sense because it goes through here. So it's going to have an asymptote up this one. It's got to go through this point. It's going to curve over, and it's going to go up the oblique asymptote. Now, I'm not sure how far down it comes. We'd have to do more analysis to get that. Here, when x is less than negative 2, I'm going to guess that this is negative because I know the bottom's negative. So it's going to come down the asymptote here, come around, and then go off down this asymptote here. And I honestly think that's as much as we'd be expecting at this stage for something like this. Later on we might differentiate and find turning points and so on, but at this stage this is what we're looking for.